Hello again, everyone. Mr. Cruze here with another trigonometry review for you. This time, review of over 2.3 to 2.4 with a little bit of stuff from a couple sections previous. Remember I gave you this review today for the quiz tomorrow. This review looks an awful lot like the quiz, so as long as you know what you're doing on this review, you should be okay for the quiz. Don't forget you can also make a note card, so if there's anything in this video that you're not sure about, might be good to add it to your note card. Just remember, no examples, alright? What I'm going to do, rather than actually go through all of these problems, I'm going to pick one from each section, and I'm going to do them for you, okay? And hopefully we can do this in one video. So, first, change each measure to degrees, minutes, and seconds. I'm going to pick the first one. So 15.98 degrees, okay? So, first things first, I just want the degrees. Well, that's the whole number part. So it'll be 15 degrees, okay? Question is, what do I do with that 0.98? Okay? To get the number of minutes, you take 0.98 times 60, because there's 60 minutes in a degree. So if I go to my handy-dandy calculator, 0.98 times 60. Okay, my calculator. 0.98 times 60. We get 58.8. Okay? So that 58, that's my minutes. Okay? Then I do the same thing that I just did. I take that 0.8, that's the decimal there, and I multiply it by 60, because there's 60 seconds in a minute. So I do 0.8 times 60, and I believe I get 48. So that means there's 48 seconds. Okay? Again, all you really need to know is take the decimal part of each previous answer and multiply it by 60, and that'll get you minutes and then correspondingly seconds. Okay? Now to go backwards. Like in I'm going to do number 6 since it's a negative, okay? To go backwards, you kind of start off the same way. Keep the degree part. That part will be your whole number, okay? That'll be before your decimal. Now to go from minutes and seconds to a decimal, you have to remember that really there's 60 of those minutes in 1 degree, right? So I'm trying to figure out what decimal that is. But also in 1 degree, there are 60 times 60, or 3,600 seconds. Okay? If you type this in your calculator as is, whatever decimal you get, that's what you're going to have after the decimal point. Okay? Just type it in as is. No need to worry about anything else. There we go. Finally working for me. So if I hit enter, I get some crazy long decimal. You'll notice your instructions say to the nearest thousandth. That means 3 places. So in this case, it'll be 0.291. So negative 40.291 degrees. Good news is you can always kind of go backwards and check your answer a little bit. Obviously, it's going to be slightly off, but you can do what you did in number 1 to check your answer to number 6. Okay? All right. Completing the table below as far as what quadrant, getting coterminal angles, I'm going to pick number 9 here to help us out a little bit. Okay. First thing I need to do is figure out what quadrant this is in. Okay, so we have negative 395 degrees, 17 minutes, 30 seconds. To figure out what quadrant this is in, I'm going to keep adding 360 degrees until I get an angle that's between 0 and 360 degrees, and then I'll know what quadrant it's in, right? If it's between 0 and 90, it'll be quadrant 1, 90 and 180, it'll be in quadrant 2, and so on, right? So let's go ahead and do that. Negative 395 degrees, 17 minutes, 30 seconds. If I add 360 to this, I'm going to go to another screen here. So it is what? Negative 395, 1730. If I add 360 degrees to this, okay, it will not change the number of minutes. Okay? This is similar to doing like negative 7.4 plus 3. Okay? We hopefully would know that the answer is negative 4.4. Notice it didn't change the decimal. Same thing here. Just adding 360, I'll get negative 35 degrees, 17 minutes, 30 seconds. It's not changing the minutes and seconds. Okay? By the way, there's a negative coterminal angle. Negative 35 degrees, 17 minutes, 30 seconds. Might as well use them. Rather than subtracting another 360, which you could do, there's a negative coterminal angle. Okay? But we still need to figure out what quadrant we're in. So I need to add another 360 degrees. Here's where things get bad, okay? Think about this negative 4.4. If I added another, let's say I added 6, okay? Is the answer 2.4? No. Actually, it's positive 1.6. Okay? Why is that? Again, it's because you're crossing over 0. Anytime you cross over 0, things that are decimals, they become switched, okay? By the way, minutes and seconds work kind of like decimals, right? In fact, that's what we spent problem number, number 6 doing? So I have to be a little careful here. So here's how I think of this. I flip it. I do 360 degrees minus 35 degrees, 17 minutes, 30 seconds. Remember, subtraction is the same as adding a negative, right? But in order to do this subtraction, I have to borrow. So 359 degrees. That gives me 60 minutes, right? But I still need to borrow again. So I need to borrow a minute, and that gives me 60 seconds. Now you can actually subtract. So 60 minus 30 is 30. 59 minus 17 is 42. And 359 minus 35 is 324 degrees. Okay? By the way, there's a positive coterminal angle. 324, 42, 30. Okay? Notice how it's not 1730, right? Like previous. Anyway, what quadrant's that in? Well, that's between 270 and 360, so that would be quadrant 4. Okay? Not too bad once you kind of get the hang of it, as long as you know the rules. I'm going to do, let's see. I'll do number 14 here, okay? Negative 214, 30, 29. So you'll notice, again, we're going to have to do what we just did, right? Let's see if I can actually erase all this. Okay, let's see, what was the number? Negative 214, 30, 29. Okay. Is that right? Yep. Okay. I'm going to add 360 because to find a reference angle, I need to know what quadrant it's in, right? To find a reference angle so that I can follow certain rules. Again, I would flip this. 360 degrees minus 214, 30, 29. Okay. Have to borrow again. 359, 60. 60 I need to borrow from again to get this 60 out here, right? Then you can subtract. 60 minus 29 is 31. 59 minus 30 is 29. And 359 minus 214 ends up being 145. Okay? You'll notice that's in quadrant 2, right? It's between 90 and 180. Well, a reference angle for quadrant 2 is 180 minus theta, right? So in this case, I need to do 180 degrees minus 145, 29, 31. Mr. Cruze, I need to borrow again, don't I? You betcha. This is 179. This becomes 60. Again, I need to borrow from the 60 to get 59 and 60 out here. So 60 minus 31 ends up being 29. 59 minus 29 ends up being 30. And 179 and 145 ends up being 34 degrees. There's your reference angle. 34, 30, 29. 34 degrees, 30 minutes, 29 seconds. Okay? That's kind of the review stuff. Again, I would make sure I have the rules. Remember that a reference angle in quadrant 1 is just itself. A reference angle in quadrant 2 is 180 minus theta. A reference angle in quadrant 3 is theta minus 180. And a reference angle in quadrant 4 is 360 minus theta. Please also note how I labeled the quadrants. They are Roman numerals, not just numbers, okay? Now let's actually get to the trig stuff. Finding the values of the six trig ratios, for each theta. I think I'm going to do number 18. I think it's slightly the simplest one. First thing you'll notice, we're missing a side, right? Good thing we can use our good friend Pythagorean Theorem, right? This happens to be c because it's across from the right angle. So a squared plus b squared equals c squared. I see that 1 plus whatever b squared is has to equal 4. So b squared is 3, which means b is radical 3. Nothing really to simplify there. Okay? So I want to find all the trig ratios for angle theta. Okay? So the first thing you need to remember, and I definitely have this on my note card at the top of every paper that I have, SOHCAHTOA! Right? Don't forget about SOHCAHTOA. You can yell it at anyone you ever see. You have my blessing. Okay? Basically, it tells us sine is opposite over hypotenuse. Well, if I do the sine of theta, opposite in this case happens to be 1, right? It's across from angle theta. So opposite would be 1. The hypotenuse is obviously 2. So the sine of theta is 1/2. Cosine of theta is adjacent over hypotenuse, right? Ka. So in this case, the adjacent side would be radical 3. Hypotenuse is 2. And the tangent of theta is opposite over adjacent, so it's 1 over radical 3. Little red alarms should be going off in your head. We can't have a radical on the bottom. So we have to multiply the top and the bottom by that radical, and we end up with radical 3 over 3, which is perfectly okay. All right. Now, we also have to do the flips of these, the reciprocals. First is cosecant. It's the flip of sine. So if sine is 1 over 2, cosecant's 2 over 1, which is just 2. Okay? Again, if sine's opposite over hypotenuse, cosecant has to be hypotenuse over opposite. Okay? The reciprocal of cosine is secant. Okay? So flip the cosine. Well, it'd be 2 over rad 3, right? Again, can't have that radical on the bottom. So we have to multiply by rad 3 over rad 3. And we get 2 rad 3 over 3. Okay? And last but not least, cotangent of theta. I would flip this step right here. Instead of being 1 over rad 3, it's now just rad 3 over 1, which is just rad 3. Notice, on these, I did not use any decimals. They want the trig ratios. Okay, no decimals. Don't type it in your calculator. Make sure you get simplified radicals. Make sure everything reduces. Okay? Alright, now for the fun stuff. Calculator business. I'm going to do the 70. I'm just going to knock it out of the park. This, they actually want the values. Okay, so you're going to go to your handy-dandy calculator. Make sure you're in degree mode, of course. Hopefully you are. And you're just going to type them in. So sine of 70. And we'll probably do to the nearest thousandth, so we'll do 3 places. So this one would be 0.9396, which would round up to 0.940. Okay. Cosine of 70 ends up being 0.342. Tangent of 70, make sure you actually type 70, is 2.747. Okay. Now the tricky part is, how do I get cosecant, secant, and cotangent? All you have to do is flip the sine, the cosine, and the tangent. So if you do 1 over the sine of 70, that'll give you cosecant. It's 1.064. Okay. If you want secant, that'll be 1 over cosine of 70, which in this case would be 2.924. And the cotangent, same thing. You just do 1 divided by tangent of 70, which in this case is 0.364. Okay? Give the measure of the angle. You'll notice this time the angle is missing. I'm going to do number 23. So the sine of some angle gives you 0.237. So notice how this is an answer similar to what we got up here. Okay? This time I'm going backwards, though. So instead of taking the sine, I'm going to take what's known as the inverse sine, also known as the arc sine. Okay? So I'm going to do second sine of 0.237, and I should get a reasonable answer somewhere usually between 0 and 90, because it's an acute angle. And I'm going to round this to the nearest tenth, 13.7 degrees. So the measure of angle A is 13.7 degrees. Just remember, if the angle's missing, use inverse. Okay? Alright, looks like I'm running out of time on this video. Hopefully this has kind of helped you. To be honest, these last questions are just setting it up, right? So if I want to find A, well, I have Pythagorean Theorem to help me find that, right? And then you can set up and you can find angle A if you want. You have 8, which is the adjacent. You have 15, which is the hypotenuse. So you can do cosine. Cosine of A equals 8 over 15. And then you can do what you did in the problems above. Okay? Again, if you have any other questions, please email me or tweet me. Otherwise, I will see you in the morning, alright? Good luck studying, guys.